Hey there, welcome back to the second part of math problem solving, where we looked at this problem last week. And the problem is LCM of A and B is 1000, LCM of B and C is 2000, and LCM of C and A is 2000. And the question asks, find how many ordered pairs ABC exist. And in order to do this, in the last video, I explained the intuition behind it, that LCM is to be thought of in terms of prime factors, and being able to figure out the prime factors or powers of the prime factors is the way you would go about solving it. So if you haven't seen that video, please go ahead and check it out. But today we're going to do an extension of this and say, okay, prove that one of these numbers has to be a multiple of 16. So that's your challenge, proving that one of the numbers has to be a multiple of 16. So let's take, for example, we know that the LCM of A and B is 1000. LCM of B and C is 2000. And the LCM of C and A is also 2000. Okay. So the first thing when you see LCM is to rewrite them in terms of their prime factors. So 1000 is nothing but 125 times 8. So 8 is 2 power 3 and 125 is 5 power 3. It's 10 cube basic, so 2 times 5. And 2000, you know, is 2 power 4 times 5 cube. And 2000 is again 2 power 4 and 5. Okay. And now every single number A, B, C could also be written as a power of this. It has to be. There's no other way that you would get this. So for example, let's think about the three numbers that contributed. So A, B, and C. So A can be written as 2 to the power of x1 times 5 to the power of y1. Okay. And B is 2 to the power of x2 and 5 to the power of y2. Okay, now reason why we write this way is for us to understand that if the LCM of these two numbers needs to be 2 to the power 3n, then you can conclude that at least one of them here between x1 and x2 needs to be 2 to the power 3 times something else, right? But at least x1 and x2, that's the intuition here. For example, x1 could be 0, absolutely. But if x1 is 0, x2 has to be 3. What if x1 is 1? So let's think of all the possible ways, and you can think of this, right? We are focusing only on A, B, only on the first one. So let's think of all the possible values here, x1 and x2. So x1 could be 0, x2 has to be 3. Because otherwise, the LCM won't be 1000. Right? The LCM, if, for example, if x2 were 1, then the LCM would just be 2 times 5 cube. Right? Which means it's 250. It's not 1000. Can x1 be 1? Yes, provided x2 is 3. Can x1 be 2? Yes, provided x2 is 3. Can x1 be 3? Yes, provided in this case x2 could be any of this, 3, 2, 1, or 0. So these are my possible ways. In fact, you can think about it and say that there's 3 such cases here and 4 such cases here. And so in total, there are 7 possibilities of figuring out x1 and x2. It has to be one of these 7 possibilities for this to work out. Okay. And similarly, for y1 and y2, you would have a similar calculation where y1 could be 0, 1, 2, or 3, provided x2 is 3, or 3, or 3, or in this case, it could be 3, 2, 1 is 0. Because in this case, y1 would contribute to 3 and the other one need not. So 3, 2, 1, 0. Okay, so in total, there are again 7 possible ways in which you can arrive at this. But our goal today is not to figure out what ABC is to also think about one of the numbers being a multiple of 16. So let's write down for the second one, you have the same 2x2, 5y2 But now you have C, which is 2 power x3 and 5 power y3. Okay, and in this case, you have A, which is 2 power x1, 5 y power 1, and C, which is 2 to the power x3 and 5 y to the power 3, y3, 5 to the power y3. Okay, so now let's think about this in a similar fashion, just like we did it for the first one. If I think about the last one, so now you know that the power of 2 in the LCM has to be 4, which means x1 and x3 have to decide how this 4 is going to be created. For example, can x1 be 0? Yes, provided x3 is 4. Can x1 be 1? Yes, provided x3 is 4. Can x1 be 2? Yes, provided x3 is 4. Can it be 3? Yes, 4. Can x1 be 4? Yeah, I mean, if you were to look only at C as isolation, then x1 can be 4. But remember, for the previous one to work, the maximum that x1 can go to is 3, not 4. Which means this is the maximum that it can reach, and therefore you can conclude that x3 has to be 4 no matter what. Because x3 is the sole contributor to this LCM becoming 2000. So 2 to the power x3 has to be 2 to the power 4. So 2 to the power of x3 has to be 2 to the power 4. Which means that's nothing but 16, right? 2 to the power 4 is 16. So you can conclude that C needs to be a multiple of 16. There is no other way that this particular puzzle works. It can work only if C is a multiple of 16. So that's your proof for today's problem. The second part of the LCM problem, which is we need to prove that one of the numbers is a multiple of 16, and it has to be C in this case because C is the one which contributes. And all you're doing is to just look at the first clause and the third clause put together to come to this conclusion. Okay, I hope you found this video interesting. If so, please do like, share, and subscribe, and I'll see you in the next part. Thank you so much.